Calculus Unit 1, Day 1 and 2 notes. This is Part 4, and I'm going to give you limit existence theorem first before we go on. We got to do a couple examples with this, and then we'll keep going on with some data tables. So what we find out, a limit can only exist, the limit of f of x as x approaches a exists if and only if the limit of the function as x approaches a from the left is equal to the limit of the function as x approaches a from the right, and both these values equals b, where b has to be a real number. So if it's not a real number, then the limit doesn't exist. Okay, and let's take a look at a few examples of these. So one of the best ways to talk about which limits do exist is to first state which limits do not exist. So this first example, find each of the following. So the limit f of x as x approaches 2 from the negative direction, from the left. Hey, it looks like it's getting bigger and bigger and bigger. So it is positive infinity. Limit as x approaches 2 from the right, positive infinity as well. Just make positive infinity for each of those. What is the value of the function? The value at x equals 2 is undefined. There's a vertical asymptote there. Well, hey, since it's undefined, then first of all, and let me write this out. So although the limit of the function as x approaches 2 from the left equals the limit of the function as x approaches 2 from the right, the limit of the function as x approaches 2 does not exist because the limit as x approaches 2 is not a real number. So let me write that down again. Infinity, positive infinity is not a real number. So therefore the limit does not exist. And the limit of f of x as x approaches 2 dne, so that's going to be our shortcut for does not exist. Because the limit of f of x as x approaches 2 is not a real number. Okay, and again, we knew the answer didn't exist because this whole section is that it does not exist. At least we think they don't exist. So let's try number 2. All right, so the limit as x approaches 2 from the left, okay, it's getting closer and closer to that hole, and looks like that hole is at 2, 2, so the limit, y value is 2. The limit from the right is equal to 2. Of course, I just said it in a section where the limits that do not exist. Well, let's see. Hey, f of 2, that's way down here. Let me do it in blue here. F of 2 is down here, so f of 2 is equal to negative 3. Well, let's go back up to what needed to happen for the limit to exist. The limit must exist if and only if the limit from the left equals the limit from the right and it's some real number. Hey, the limit from the left is 2, the limit from the right is 2. 2 is a real number, so does it exist? It does exist. And let me write out why. And I said it because 2 is a real number. Okay, and just so we see it, the limit of f of x as x approaches 2 exists because the limit of the function as x approaches 2 from the left is equal to the limit of the function as x approaches 2 from the right, and it equals, and both those values equal 2, and 2 is a real number. Okay, so it doesn't matter that there's a hole there, and it doesn't matter that the value of the function equals negative 3. The limit from the left equals the limit from the right. All right, and let's look at the third example. So find a value of this function as x approaches 2 from the left. Let's see, as x approaches 2 from the right. Okay, and now and I should have been writing these numbers in. So as I approach 2 from the left, it equals 3. As I approach 2 from the right, it equals negative 3. This time, it has value of the function f of 2 is equal to positive 3 as well. So right now, f of 2 equals 3, and from the left equals 3. But again, what did our limit existence theorem talk about? Really was just, does the limit from the left equal the limit from the right? And in this case, it does not. So since I know, and I need a little more space here, since I know the limit of the function as x approaches 2 from the left does not equal the limit of the function as x approaches 2 from the right, then I know we can conclude that the limit of the function as x approaches 2 does not exist. Okay, and so let's look, what do we got here? Jump discontinuity. Limit doesn't exist. What do we have up above it? Hole. Limit exists. What do we have up here? Vertical asymptote. Limit does not exist. Okay, so again, all based on the limit existence theorem, which says limit from the left must equal the limit from the right, and that value must be a real number. So here, positive infinity is equal to positive infinity, but it's not a real number, so therefore the limit did not exist. And let's do this last little part here. Based on what you have seen so far, does f of a have to be defined in order for the limit of f of x as x approaches a to exist? And I just went through and explained that, but let's come up and draw and explain two different graphs to justify your reasoning. In both graphs, f of a should be undefined, but in one graph, the limit should exist, while in the second one, it should not exist. So from what we just did in those three examples, see if you can come up with your own graphs, and then I'll pause it and you can watch in 3 seconds and see how you did. Okay, so here's what we have. F of a is undefined in both cases, but here the limit exists on this left picture, just because the limit from the left equals the limit from the right. And again, it's a hole, which we'll now start talking about as a point discontinuity. Okay, over on the right, it's f of a is undefined, but the limit does not exist because the limit from the left equals this value, whatever it is up here. The limit from the right equals this value down here, and that's a jump discontinuity. So the limit from the left doesn't equal the limit from the right. Okay? All right, let's go on and try some of these other problems.